So I want to go back through kind of things that we had known about before. These all made lines when we graph them. Okay, so I'm just making up. Those are not real. Those are just making straight lines. But we realized from yesterday's lesson when we start talking about this parabola, which is this blue piece, there's some new information that, some of it we might have heard before. X-intercept we've heard before. We've probably heard about, X-intercepts as well. But the newer terms are like axis of symmetry and vertex. Okay? And so, but we started talking about how a parabola graphs. And this right here becomes your best friend when doing these. Okay, this is also related to the axis of symmetry. So the x part of the vertex, this is the axis of symmetry all the time. And the axis of symmetry is written as a linear equation, so it's x equals a number. Okay, so if this was known as our vertex. Okay, so that's kind of the ins and outs. We also talked about the y-intercept. The y-intercept is always going to be 0, c when our equation is written like this. Excuse me. Must be COVID. I'm just kidding. It's malaria. So we did this problem yesterday, yes? Do we agree? So just a few things that we noted. We use negative b over 2a. We label a. We label b. We label c. And that's going to help us along. And what my goal is, anytime we do these graphs, when they're set up in standard form, so x squared to a number, we will always be doing it the same way. I think when I got part of the way into this problem yesterday. Agree? Yeah. I did not finish it though, or did I? No, okay. All right, so let's talk about how this one's going to work. So I know that I'm going to call the very middle of my graph, I'm going to put a V for vertex. And it's real easy to set up our table once we have pattern graphed. Okay, so I believe we did negative b over 2a. I can make things look nicer. And then we know that a is negative 2, b is equal to 8, and c is equal to negative 2. Okay, I think because of that, we knew that our y-intercept being at 0, c, we can go ahead and say that we know that we have 0, negative 2. So 0, negative 2 is right here. And our friends, the y-intercept is not always a critical value to know. It isn't a vital point. It just sometimes will give us some direction once we find our vertex of what our graph should look like. So things that you should probably note on this is being that my a value is equal to a negative number, the parabola will open down. Okay, so that's kind of a thing to keep in mind when you're doing these types of things. So let's just, I know I probably started this, but let's just go through the rest. So I have negative b over 2a. That means I'm going to go negative 8 over 2 times negative 2. And I'm going to just do the fraction. That's going to be over negative 4. So negative over negative is positive. 8 over 4 is 2. So I find that x equals 2. 2 is the x component of our vertex. And it is also our axis of symmetry. Okay? So I'm going to go ahead and draw in our axis of symmetry. I'll do it with a dotted line. Remember, the axis of symmetry is always a vertical line. But that's basically the ins and outs of what we've done so far. Okay? So what did we say we had to do to get the rest of the vertex? What do we have to do to get the rest of our vertex? So we know that x is equal to 2. So I can plug 2 in for what and where? What do you think? Yeah. Yeah. Yeah, you're going to take this 2, which is an x, and you're going to replace it with those. Now, any of the math that's taking place with those problems, that's fine. So I know I have y equals -2 parentheses squared plus 8 parentheses minus 2. Where those parentheses are in that new equation is where x used to live. And we're going to plug 2 in to each of those now. Does that seem to make pretty good sense? All right, so we do the math. Exponent first. 2 squared is 4. 4 times -2 is -8. So I get y equals. And then 8 times 2 is 16. And then I have the -2. Does everyone feel comfortable where the numbers just came from? So from there, I'm going to say, all right, let's do the arithmetic. -8 plus 16 is +8. 8 minus 2 is 6. So I'm going to go ahead and plot the point 2, 6. So should our vertex fall on the axis of symmetry? Does that seem to make sense what I've talked about yesterday? Axis of symmetry is always the vertical line that we can fold over on top of itself. So the vertex will always live on the axis of symmetry. That's why the x equals -b/2a finds us the x component of the vertex. It also finds us the axis of symmetry. Now, I'm going to tell you that there's 2 other parts that come with this. If you take a future math class, we don't teach it here. But like if you were to take college algebra in college, there's going to be 2 terms that they make, and I will tell you. One's called the Directrix, and one's called the foci. Okay? And they're an equal distance above or below the vertex, but it's not something that we focus on here, but sometimes in future classes, especially like college algebra that's not taught here, they will talk about the foci and the directrix. Okay, but as far as we go, so if any of you have an outside tutor, they're going to be like, okay, do we have to find the foci and the directrix? No, we will not be expected to do it, okay? All right, so now there was a new concept that we talked about, and in one of my classes, they had a little bit of anxiety, but I talked about the A times 135. And the 135 for pattern graphing, that will continue forever. It's 1, 3, 5, 7, 9, 11, 13, 15, 17, forever and ever. But you get to a point where you're going to pattern graph right off your graph that's given. Okay? A lot of times in here, we will probably just use the 1 and the 3. The 5 might be off our graph completely, so we're not going to worry about it. Okay, so what's my A value in this original equation? -2. So I'm going to go -2 times 135. So that means I'm going to pattern graph at -2, -6, -10. Okay? Now the nice thing when you pattern graph, it's always done the same way. It's always to the right and to the left, and then whatever the value that's given. So from this one, I'm going to go for my vertex, I'm going to go right 1 and I'm going to go down 2. And then from here, I'm going to go left 1 and down 2. So the nice thing is you could figure out what those points are. That's the point 1, 2, 3, 1, 2, 3, 4. So this is the point 3, 4. And this point here is the point 1, 4. Do you feel comfortable with how I established those points just now? All right, let's pattern graph one more. So we took care of that. Let's take care of the 6 now. We'll do that in green. Okay, so for my new points, I'm going to go right 1 and down 6. And then I'm going to go back to my orange dot, and I'm going to go left 1 and down 6. And notice that dot also fell on what we labeled as the Y-intercept. That's fine. It doesn't always happen that way, but it's totally fine if we had labeled something one way and it went the other. So then my parabola kind of looks like this. Should be kind of a smooth curve at this top. Okay, and I can even find these points. So that's 1, 2, 3, 4. down 2, and this is 0, negative 2. So then you can go and start plugging into your grid. You can say, oh, you know what? I know that I have 3 and 4 that work as a point. I know that I have 5 and negative, or 4 and negative 2. I know that I have 1 and 4, and I know I have 0 and negative 2. So it's real easy to fill out the t-table. Now, unfortunately, some teachers are going to teach the t-table as the very first thing in this class, which means they are literally finding the vertex and saying, okay, what's the number to the left? 1. Plug 1 in. 1 squared. 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 times 8 times 1. That's negative 2 plus 8 minus 2. And you can still get the same answer, but it's a lot further unless you realize pattern graphing. Yeah. No, I just always make the vertex in the middle and then just go right or left as top and bottom, and then 2 right, 2 left from the vertex for beyond that. So technically, like the order don't have like 0, negative 2 is negative 2, 0. That's a different point. But as far as the order, the t-table is not like a key pivotal thing. If you can graph these using the pattern graph, if you have a nice grid, you should be able to see what points would work. So the t-table is not like the most vital thing in the world. I just kind of put it there because that's what they had as part of the lesson. Okay? Hey, friends, does this make sense why this graph would open upside down? Does it make sense why I'm using, for pattern graphing, negative 2, negative 6, negative 10 rather than 1, 3, 5? The pattern graph is always A times 1, 3, 5. If A is positive, then 1, 3, 5 just multiply by whatever A is. If A is negative, all the 1, 3, 5s will become a negative value to dictate which way it opens. Okay, so do we feel relatively comfortable so far with what we've done? Do you have a good amount of information you've written down? Is there one more parabola on our sheet? Okay. It's this one, right? Okay. All right. So, a couple things to note about this problem. Am I missing a value? If so, which value is it? A, B, or C? C. If C is missing, what placeholder of a number do we put in? 0. Okay, so this is technically plus 0. That's the same exact equation. It's just we're recognizing that our A, B, and C. So I'm going to go negative B over 2A, and I'm going to go A equals, B equals, and C equals, and I'm going to go ahead and list those. Okay, A equals 3, B equals negative 12, and C equals 0. We could start answering more of this. We can say the y-intercept is always 0, comma C, so what does my y-intercept have to be? 0, comma 0. Okay, and again, that's just an additional point that we're going to establish. So this 0, comma 0 is happening on our graph. Friends, does this parabola, just by looking at it, open up or down? Up. Why does it open up? You're absolutely right. The positive A. Excellent. So you're using some good terminology to indicate that you're showing understanding why things are going to happen a certain way. All right, so I'm going to use the negative B over 2A. So I have negative, what's my B value? 12. Careful. Negative 12 over 2 times, what's my A value? 3. Notice on top I have a negative, negative 12. Agree? What's negative, negative 12? Positive 12. This is going to be x equals, so x equals 12 over 2 times 3, which is 6. So x is equal to what? 2. That's my axis of symmetry. X equals 2. That's also the x component of my vertex. Notice how I just used that black pen to indicate multiple locations of where we're finding this. Not all problems will give you a t-table, and that's okay. But the nice thing is you have this axis of symmetry. Axis of symmetry is positive 2. So you're going to go over to positive 2 and write in your axis of symmetry. So technically this is the line x equals 2. Okay? And we'll call axis of symmetry AOS. Okay? Is there any part of this problem that we've done so far that you're not sure about what we did? Okay, my friends, how can I find the rest of my vertex? Plug in, what am I plugging in? You're absolutely right. The x, what's the x equal to? 2. So I'm going to take my original equation, which is this, and then I'm going to plug 2 in wherever I had an x. And we're going to do the math. Okay, you have to know that 2 times 2, or 2 squared, is 4. 4 times 3 is 12. 12 minus 24. Because negative 12 times 2 is 24. So I get y is equal to negative 12. Okay. So this kind of creates a little bit of a problem as it sits. The reason it creates a little bit of a problem, negative 12 is off our grid. Agree? So we could do one of two things. I can kind of guesstimate where 2 negative 12 is, or I could count all of my little tiny subsections as count by 2's. Both of them are correct ways of doing it. I kind of like, because this is barely off our grid, I realize, okay, 2 negative 12 is like down about here. That's our vertex. Is that okay? Yeah, it's off our grid a little bit. We know it's off our grid. It's 2 off our grid. If I gave you like 2 comma 26 or something like that, that's way off the grid. So we either have to make our grid bigger, or we have to start counting the little tick marks on our graph by a different number rather than 1. Okay? And again, I think they're both correct ways of going through it. Friends, are we ready to pattern graph at this point?
So, do we find the roots? Like, how do we find them?
Oh, we're going to get there in a sec. We might find them. Did the last one ask for roots?
Yeah.
Did it? Ooh. Hey. Okay, I'm back on the screen. Okay, so friends, let's pick a color we haven't used. Oh, look, let's do puke green. Right here and right here are my roots. I don't know exact roots at this point, though I do know that it does cross the x-axis. Okay? Now, sometimes when we pattern graph, our pattern graph, if we do it big enough, will wind up crossing the x-axis at an exact point. Right now, those roots that are up there, if I were to have done, and remember, this is back a problem. If I had factored negative 2x squared plus 8x minus 2, it probably would not have factored. Okay? This would have been one we would have listed as prime. Okay? So when it factors, it means it comes out to a rational number. A rational number, which you might not be familiar with, is either a whole number or a fraction or a decimal that is a repeating decimal or a terminating decimal, meaning you could make it a fraction no problem. This one, I don't know if it, I don't think, I'm pretty positive it's not going to factor. If you use something called the quadratic formula, which we haven't gotten to yet, you would actually find out that the roots are probably an answer something like 3 plus or minus square root 2 over 7 or something like that. And you're like, what? Yeah, don't worry. We'll get there. It's not tough. It's just one of those goofy things. So let me go back to the problem we had. I'm sorry, I didn't have the roots on that last one. Okay, so my friends, am I ready to pattern graph on this? And if I pattern graph, what's the equation I use? A times 135. Very good. What's my A value? 3. So it's going to be 3 times 135. So my pattern graph is going to be 3, 9, 15. Okay? All right, I think we can do this. Ready? Remember, our vertex is off the grid. It's off the grid 2, right? So I'm going to go right 1, up 1, 2, 3. And I'm going to go left 1, up 1, 2, 3. So I could easily find these points. This is the point 3 comma negative 9, and this is the point 1 comma negative 9. Is that okay? So let's pattern graph for the 9s now. Okay, ready? I'm going to go right 1 from that ugly color. I'm going to go right 1, and I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's the point 1, 2, 3. That's the point 4 comma 0. And then for here, I'm going to go left 1 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice, did that find something? That green and red dot are the same. Okay, so being that my y value is 0, my roots are 0, 0, and 4, 0. Okay, and then we could fill in the rest of our graph. We can say, okay, to the right, I'm going to go 3, negative 9. To the left, I'm going to go 1, negative 9. If I go to the right one more, I'm going to go 4, comma 0, and 0, comma 0. So we filled out the t-table just looking at our graphs. Have we answered everything on that? We've answered everything. Only thing left to do is make our parabola. Oops, I can make it better. There's our parabola. Okay? So this is different than what we're used to. Agree? So let's kind of sum up. Let's get some rules in place. So if given y equals ax squared plus bx plus c, we can find the x portion of vertex and the axis of symmetry by you doing x equals negative b over 2a. That's our first move. Draw vertical axis of symmetry. And then plug x value into original to get y. And this is going to get us to our vertex. Okay. And then after that, we're going to pattern graph which is going to be a times 135. Other things that come along with this, we can find the y-intercept by doing 0, comma c, and that c comes from above. And then right now we can find roots if pattern graph lands on x-axis. That's everything we've done. Okay, and it's a lot, but the nice thing is it's the same equations you use over and over and over. Okay, the nice thing is by you practicing something over and over and over, it becomes routine. It becomes a routine that means you're going to remember it. You're going to remember it in geometry and algebra 2 and other classes that you might take here as well as at a university. I can tell you that the x equals negative b over 2a is not taught at every school, USA. Okay, they do other things. We have found by having a very same pattern each time, it works. It's also what we did with factoring. Okay, we tried to do factoring always the exact same way every time. So those are some helpful hints. Now, some things that could get goofy. And this is not really part of your notes. Does everyone have that written down? Anyone need more time? Good. So things that can get goofy. So we have, say something like this. Well, we know A is 2, B is negative 4, C is equal to 6. That's probably straightforward. But what happens if we had this? Which value is missing? B. So I know that my A value is 2. My B value is missing, so we're going to put a 0 in as a placeholder, and my C value is 6. But we also could have this kind of situation take place. So which value is missing? I just wrote the same thing over again, didn't I? I'm being a ding-dong. We could also have this situation take place. Which value is missing here? The C value. So we would know the A value is 2, the B value is -4, and the C value would be 0. So these are some characteristics that can take place. Okay? We're going to do some other things that are going to lead to it. There are times that we might get these that are already factored next week, which will kind of lead you through this a little bit. But my friends, I believe that you have good enough notes that should be able to help you along with the assignment. And we don't come back to school until Wednesday. Is that right? So let's focus on... So kind of the nice thing that comes with this is photo math doesn't necessarily work to solve you every part of the problem. I would strongly encourage you to try and steer away from photo math because it's not helping you to go along with these. Okay? I do have the odd answers posted in a folder. It's under the GQF folder underneath this week. When I graph these, I just graph them quickly. I don't necessarily go through all of the questions. But I'd like you to work on page 83 and 84. And it's 4 problems. So do all of it. Try and answer all the questions. I'm happy to help you if you need any help right now. Let me just save my video.